Hi everyone, today we'll see how to calculate this NDWI calculation using ArcGIS by the data Landsat TM image and ETM as well as OMI image, that is Landsat 425 and Landsat 7 and Landsat 8. So this PowerPoint is prepared for video tutorial. So the first thing is remote sensing data. So remote sensing data are used to find out change detection in recent decades. So these remote sensing data are relevant for the calculations of this NDWI index calculation. So remote sensing data such as Landsat, Sentinel data, spot image, etc. are very useful for visualization, classification, and analysis of steady area. So for analysis of normal difference water index, mostly three bands are mostly used. These are green, near infrared regions, and SWIR. So when you come to NDWI, normalized difference water index is used for the water body analysis. So NDWI is sensitive to build up lands and result in overestimated water bodies. So this NDWI products can be used in conjunction with NDWI. So this is used to assess apparent change occurrence. So generally, water bodies are in their liquid states are generally high reflectance on blue spectrum than green and red spectrum. There is also Landsat 7 ETM, enhanced thematic mapper, that is with their color coding. So as you can see, there is blue spectrum, green spectrum, and red spectrum. So these are bands. So clear water having a greatest reflectance is in the blue portions of the visible spectrum. So water appears blue. So turbid water has higher reflectance in visible spectrum. So NDWI is developed by Zhao 1996 to enhance the water-related features of the landscapes. This index uses the near infrared region and the shortwave infrared bands, that is SWIR and NIR. So NDWI is mostly used to determine vegetation water contents, that is moisture contents in plants and soils. So it is calculated as a ratio between the NIR and SWIR values in traditional fashion. So as you can see, this is the equation for estimations of vegetation water content, not the change in lakes. So this information, this equation is relevant for the vegetation water content estimation. So for Landsat 7 data, there is NIR is band 4, as you can see, band 4 NIR. So we can see from the earlier picture NIR which band is NIR and SWIR is which band. So 4 and 5, I think. So we'll see here the Landsat 7 NIR is band 4, as you can see, and SWIR is band 5. So for Landsat 8 images, this bands will be changed. It's because NIR is located at the band regions of 5. So we will change these bands, so we can get for Landsat 8 data in such equation. But result appears from the these two formulas is poor in quality. So the pure water neither reflects NIR nor SWIR. So the formula of NDWI is then modified by Zhu in 2005. So NIR will be changed because this NIR brings the result with poor quality. So Zhu modified in 2005 by replacing this NIR band with green band. So will be modified in such a ways. So NDWI according to this 2005 can be created in such a way. So for Landsat 7 you can use these bands. So as I said before, you will seek which band is for Landsat 7 is green, and for Landsat 8 which band is green also, and SW shortwave infrared region which band could be. So you need to refer this picture. So for Landsat 7 the green section is band 2. So the green section for Landsat 8 here it differs, it points in band 3. So band 3 and band 5 are for Landsat. That is band 6. Band 6, as you can see, are the main bands used to equate this NDWI. So this normalized difference water index values mostly lies between -1 and 1. So vegetation has smaller, much smaller values, which distinguishing vegetation from the water body easily, as you can see. That's why the more the lower value, the more the vegetation occurs. So built-up features having a positive values lies in the range between 0 to 0.2. There are 3 types of models for Landsat 8 OLI bands, so we can calculate using 3 models. The first one is using this model green and SWIR1, and the second model is using green and SWIR2 as a ratio, with green and green plus SWIR2. So the other one is using NDWW green and NIR. So the third model is mostly and relatively better result, gives a better result in estimating the lake expansion effects, as you can see. So for today we will see change in area of lake using this model. So generally the range, the class of NDWI should be greater than or equals to 0.3 to indicate the water body. So I'll straight go to the steps followed to do NDWI calculation. So the first step to do is data acquisitions. So the second one is check the image for correction and do conversions of this digital number to top of atmospheric radiance value. So the equation to convert this digital number to top of atmosphere radiance. So this top of spectral radiance can be equated with band specific multiplicative rescaling factor from the metadata. So we will explore this ML. So we will use this multiplicative respective factor from the metadata. AL is band specific additive rescaling factor from the metadata, and QCAD is quantized and calibrated standard product pixel values, that is a digital number. The third one is I need to mask the study area under change, that is a lake. I need to prepare a mask map for my lake. So after just I masked my area, I need to calculate NDWI using map algebra. So this map algebra can be used in estimating, correcting this Landsat image by converting digital numbers to top of atmospheric radiance. So I will begin by starting how to convert this digital number into top of atmospheric radiance. So the first step is data acquisition. As you can see, this is my new folder. I have got this data. So there is 2015 here. As you can see, this is 2015, 2020, 1985, 1990, 1995, and 2010. So I gathered this Landsat images based on a minimum snow cover. So it might be Landsat 5 or it might be Landsat 7. So here these are Landsat 5 images with low or a threshold cloud cover, that means less than 10% cloud cover. So I will open with a notepad. As you can see, you can explore sensor ID. As you can see, sensor ID is TM, so Landsat 5 TM. So all information are here available here. So I will use this radiance and here reflectance. Here the spelling factors are here, so I can correct using this band factors. So here, as you can see, this is the equation. Top of atmospheric radiance, where this one is top of atmospheric radiance, where ml is band specific multiplicative or respective scaling factor from the metadata, that is this one, reflectance multiband. This is for ml. So for band 1, band 2, band 3, this is ml. It differs according to bands, where QCal is digital number and AL is reflectance at band. As you can see, it differs here also based on bands here. So the first one is I need to correct 1985. I'll show you how I did correct this 1985 with this equation. So I will not show this 1990 to 1995 and onwards. It's because it takes time. It will be a long video, so I'll begin here. So Landsat 5 TM, it is a TM sensor. So I need to open the picture. Which bands are necessary for the calculations of this NDWI? So TM sensor Landsat 45 is here, as you can see. As you can see, I can open this image. So TM image here. So band green and NIR is necessary. So green region located here, band 2. So NIR located here, band 4. So I need to correct this band 2 and band 4 for this 1985 image. So I will collect band 2 and band 4 from 1985. So I'll open. This is the data for 1985. So I need to correct this band 2 and this band 4. So in order to do this and to open metadata here, this one. So when I open this, it looks like this one. I need to open using WordPad. So the first one is ML is here, as you can see. ML is reflectance multiband, whereas AL is reflectance adband. So reflectance adband and this is factors for conversion. So the first one is for multiband 2. I need to copy this one, and this one. As you can see, this is band 2. This is band 4. The other one is reflectance adband. As you can see, adband here for band 2 you can use this one, and for band 4 this is. So in such a way you can grab here, you will collect here and put it into the equation. This one here, ml, in place of ml I did insert this one. This QCal is digital number, so I strictly use the raster band here. Using sales, using map algebra, I can convert this raster using this factors. So for band 2 I use this and this rescaling factors. So for band 4 in such a way I can convert. So I will use this both equation to convert this 1985 image. So let's see. So I need to add here new folder here in desktop. So new folder here, this is data obtained, and to add this band 2 and band 4 for 1985. So I need to activate this box. Click here yes, Yes, mostly these Landsat images might be necessarily correct for radiometric, geometric, and atmospheric correction. So this L1 TP images are mostly corrected for geometrically corrected, so you can escape any correction, but mostly the conversion of digital numbers to top of atmospheric radiance is necessary for calculating indices. So this is UTM in Landsat image. So I'll open here spatial analysis tool here, map algebra, as you can see, and then finally Raster Calculator. Open it. I will see how I can change these bands for the year. I need to create a storage location. So the first one is equals to bracket. So I need to correct this band 2. So band 2, I need to correct this one. Copy this one. Copy times. This is band 2, I think. Yeah. Double click to open. To add, that is, then plus. So plus this one. Copy. So plus minus, you can delete the plus. Okay. So finally, we need to choose storage location. Desktop here, 1985. Corrected. So open it here. Here band 2. Here. .tif. It's a raster because you need to don't forget to add this .ti extension because it's a raster. So save, then finally OK here because there is time constraint. So this is band 2. As you can see, in such a way it's already corrected. So I will no longer want this band 2 because I have already regained the corrected one. So in such a way I can convert the band 4 here, okay, no, bracket, copy this one here, paste it, times the second one, this is band 4, double click, plus this one rescaling factor. So saving folder, same folder, so band 4. So okay here, .tif, don't forget. So okay, so I am no longer needed such uncorrected digital number image. So I need to remove this one. So the other one is I need to calculate NDWI. So NDWI, as you can see, NDWI here, this is for water content. So this is for lake. So I use this one, green minus in higher. So before that I need to mask my study area. So these are the lakes I'm going to study. So I need to prepare a mask. It's because the other step is to prepare a mask. It will reduce the processing time, which will take by ArcGIS. If you use mask data, the data entry to process will be small, so processing time will be short. So I need to prepare mask data. So here, as you can see here, polygon, you can draw. This is my study area. This is my study area. This is my mask study area, so I can prepare mask polygon in such a way. So finally I need to convert this feature class into shapefile, then I can extract these parts. So here, as you can see, I need to convert this graphic into features. So here, new folder here, this is mask 1, okay, mask 1, okay, shapefile. So okay, I need to import it here. So I need to delete the graphics one. This is the shapefile. This is mask, so I need to extract these bounds using by this mask layer. So extraction here, extract by mask here, input mask. This one is the input mask. You can drop. Okay. This is input raster, so I can mask this one. This is a raster. Input mask feature class. This is this mask one. So band 4. Let's make different band 1, band 4. Sorry. So this is masked 1. So the other one for band 2. So I have already completed. So I no longer need this one. So this is a masked lake. So I need to compute this NDWI using band 2 and band 4. So where band 2 is green, and whereas band 4 is for NIR, near infrared region band. So using map algebra, I need to compute NDWI. So there is map algebra here. Okay. Here, as you can see, there is a float. So band 2, double click, minus band 4, double click, divided by, here click float, band 2 plus band 4. So output raster NDWI will be exported here. This NDWI. So the value greater than 0.3 is a lake, the other is, I think, not a lake. So we can classify this image. So based on steps, I have prepared the study mask and calculate NDWI using this in such a way. So convert reclassified rasters to polygon. Before that I need to reclassify the raster. So I need to reclassify this raster. Right click, properties, here, go here, symbology, classified. As you can see, there is 0.3. Okay, this is not actually properties. Here, classify, let's make it 0.2. Yeah, now as you can see 0.2 is the lowest margin. but it might be different from papers, from resource papers to resource papers, because in many papers the lower threshold which indicates water body is 0.5, and some others say 0.3, and some others also say between 0 to 0.2 it is urban land, the rest above 0.2 it is water land. So when I make it 0.2 it shows the lake precisely, so I reclassified the raster in such a way. So I need to convert this raster to polygon. I need to reclassify this image. We'll search, classify our special analysis tools. Reclassify. As you can see, input raster is this one. So from 0.2 this onwards it is 2, from this is 1. So classify. So I need to expose this reclassify. As you can see, I did already reclassify the raster in such a way. So the other step is to reclassifying the raster. I need to convert to polygon, because I need to reclassify. So polygon raster to polygon, I need to convert in such a way. So from raster to polygon, input raster is this one. It is reclassified. So based on value, yeah, polygon feature, it can be reclassified. 1985 polygon. Measure class, its shape here, extension is added here. So okay, I did here. So this is polygon. You can open the attribute table and you can dissolve based on grid code. You can dissolve. So here, go here. There is a dissolve here. You can search your processing, dissolve. Input feature. This is input feature. So based on grid code, you can. So 1985 only enough. So there is a shape here, so no problem. All are optional, so okay. As you can see, this is a dissolved image. You can open the attribute. You can also add. You can add here add field. Area of the lake, short integer double here, precision you can give 15, scale precision 5 is enough, scale 5. Here right click over here, calculate geometry, here area in which you want here, in which unit you want here, in hexa, in square kilometer, so in square kilometer, okay, square kilometer. Here as you can see, this is area in square kilometer. It's already done in such a way. So you can add a 1985 NDWI 1985 shape, then attributes. Your area is already calculated, so I no longer needed here this one. In such a way, I did calculate for the year 1985 by correcting the image. So in such a way, I can do for the other. The first one is for 1985. If I do for 1985 you can do. This is Landsat 5, so I will do also for Landsat 7, and I will do for Landsat 8. So you will see this is Landsat 5, this is Landsat 7, this is Landsat 8 image. So I can do using 3 images 1985. So using this, so this one I can use 3 years image to calculate the change of the reduction in area of lake. I can investigate using this 3 years. You can for your research paper you can increase the number of years based on your interest and based on your time. So if I increase the time of study, it might be time intensive as well as capital as well as energy, so I need to save my time. So this is to help how we can NDWI calculation. So I will begin. I will remove this one. Again, how I change by adding this 1000 image. So 1000, this is 1000. So 1000 is Landsat 7 image. So which one is important band for me to calculate NDWI? So NDWI. So for Landsat 7 I need green and near infrared region. So green is for here band 2. So for NIR it's band 4. Band 2 and band 4 are for me relevant to calculate this NDWI. So I need to add those images. So add here. Okay, so I added. So I need to convert this this image digital number into the type of atmospheric radiance. So in order to convert this I need to explore Landsat 2000 image, this 2000 image. So mtl.txt extension here at the bottom. So I need to open this in Notepad. So open WordPad here. Sorry. So the first one is multiband. For band 2 I use reflectance multiband to copy this one. Copy here 2000. So this one convert here. What about band 4? I need to convert as well. Band 4, this one. This is for band 4. So I have already finished. So I need to strictly go to map algebra. So no problem, here go. Try to zoom it, so I don't want to mask this time. So map algebra is here located in special analysis to see Raster Calculator. So the first one is to open the bracket. So I need to copy this one. This is band 2. In place of band 2, I need to double click this band 2 back. So this is it. Finally here, open 1000 image, desktop, 1000 folder. So here, image, okay, here, okay. So it's already converted here, so I no longer need this one. Remove. Go again here, Raster Calculator. Copy this one. Paste here. In place of band 4, I need to convert to this one. So this, yeah, it's okay. Here plus minus. If you leave, it's okay, but you can delete here plus sign. Plus times minus, it's minus here. So band 4. Band 4. save. Okay, so already converted here. So I go to this bands. So what I'm going to do is calculate NDWI, or I can extract here by mask. So extract by mask, extraction by mask, input raster. So this one, okay. Input raster, this one, this mask, band 4 dot diff 0. Okay, so I no longer need this one. By mask, input raster, mask, band 2, okay. So I did prepare in such a way, so I no longer needed this one. So I go strictly to estimations of NDWI using Raster Calculator in map algebra. So which is equals to float is our equation, band 2 minus band 4 divided by, again float here, divided by band 2 plus band 4. So here NDWI, saving folder, save. Now here, so raster, so NDWI, so save. Okay, I can strictly go to reclassify, class here, reclassify, input raster, this one. So here 2 0.2, I need to do the same. So okay, 1 and 2. So reclassify, reclassify dot diff. As you can see, I did convert. So no, it's not right. Here 2, classify 0.2. Okay, apply. Okay, so reclassify, no problem, it's okay. Raster to polygon conversion tool. With conversion, sorry, from raster to polygon. So I need to calculate the area, which is input raster, field value. So reclass polygon. Can you give a name? It's a shape, so that extension. So I need to resolve this one. Input feature, this one, grid code, saving folder, 2000. Enough. Yeah, this is a dissolved image, so attribute table. What about this one? This is a lake. This is no data. This is a lake. The other is not a lake. It's not a lake. So I need to calculate the area by adding field. Area data type double, so precision gives the same as before, 5.5. okay, yes, yeah, in square kilometer, the same as earlier for comparative purpose. As you can see, this is no data region. These are for calculator land. This is for lakes, water area. So for Landsat 8, as you can see, the bands needed are band 3 and band 5. You can check from this picture. For land 8, there is a green band is located here, band 3. So for NIR, there is here band 5 located in band 5 region. So band 5 and band 3 is relevant to calculate the NDWI for Landsat 8 image. So I need to calculate top atmospheric radiance, so I need to convert to the digital number. So these are the numbers for rescaling factors, as you can see. So I need to insert in this equation. So I will go strictly by adding the image. So add image 1020 is here. So band 3 and band 5 are important here. I need to add here. So yeah, so I need to convert this. So map algebra, Raster Calculator, copy like we did before, copy, paste here, no space here, no plus here, band 2 here, band 3, but band 2. So saving folder 2020, so open 20 here, give it a name, band 3. Corrected. .tif, so raster dataset, so don't forget at any time. So the other, it's not band 3, band 2, this is band 3, this is band 3, this is also band 5. Okay, this is band 5, so copy here, no space, if there is space remove, and plus sign also delete, and convert this one. And 5, saving folder, band 5 corrected. .tif, yeah, as you can see these are corrected, and we need to remove the original data. So I need to mask this study area, so I need to mask this study area. So special analyze tool here, there's extraction of my mask. So input raster, let's extract this one, mask here, output. The output file name can be band 5 mask .tif. So save. Okay, the name is large, it's okay, you're okay. Band 3 mask, save. Yeah, yeah. So I no longer need this both. So I need to calculate the NDWI here using map algebra here, Raster Calculator. So band 3 minus band 5 divided by, here also again plot band 3 plus band 5. So the output file will be NDWI .tif. So raster. So I no longer needed this masked files. So as you can see, you can classify here. Classified to classify 0.02, 0.2. Okay, apply. Okay, so finally reclass. So reclassified. .tif, save. So this is reclassified. So I need to convert this reclass into a shape file using a conversion tool from raster to polygon. The same repeated work. So input field value. So this is polygon files. Okay. So I need to resolve this image. So poly grid code, which is (2020). So area. Okay. As you can see, this is dissolved of attribute dissolved. So I need to add field area short integer double here 5 like we did before. Okay, copy geometry. Yes, and scale kilometer here do the same. Yes. So we can analyze the rate of change of historic area. So we can open Excel. So this is the water area. So this copy. (1985) 2020 area in square kilometer. This one. Area in square kilometer. Years. Decade years. Okay. This is square kilometer, so I need to add 2000. So area. This is not the area. This is no data, and this is for the lake. So copy this one. As you can see, there is a reduction. Yeah. For let's see, for 1985. So add 1985. This is not the lake region. This is a lake region. So copy this one. So you can extrapolate. You can. This is the final output for my study area. This is my study area is on lake, so there is a gradual decrease in area of coverage of water body. The area reduction is unbelievable. This is so steep, as you can see, from 1980 to 2020. Within 30 years, there is a huge change in the coverage of the area of the lake. So the reduction can be equals to this one minus this one square kilometer. The area of the lake decreased by 38 square kilometer, which is so huge. So water study professionals should analyze the area. So this is not a small number, it's a very huge number. That could be the reason for reduction in the area. Someone needs to give a justification. So in such a way, you can do this NDWI calculation. You can also project for the remaining 2040. You can project in such a way. So let's add trend line, display our equation on the chart, linear equation. Okay, so using this equation we can extrapolate equals to this one bracket this one times this one plus as you can see there is a huge reduction. For 2040 it will reduce to 2000 within such a rate. It will be 643.788 square kilometer. So the area needs special emphasis in restoring the hydrology of the area and the ecosystem as well. So this is all about for today. Thank you very much. Have a good day.